So this is lesson number 33 in Algebra 2, and the name of this section is called Major Rules of Algebra and Complex Fractions. So we are going to start about the middle of the page here and start with a couple facts that there needs to be known. When you have a fraction like 4 over x plus y and you want to add p over y all over x to that, one thing that the book says and highlights it, which is very true, is that when there is no equal sign present, you have what is called an expression, and you cannot eliminate the denominators. You can't make those go away. Now, we've learned in the past that if you have 1/3 plus 1/4 equals 1 over 6, if you multiply this entire thing by the common denominator of 3, 4, and 6, that multiplied by that, and that, your fractions go away. So that was a real handy thing to use, and it is still a good handy thing to use, but we cannot do that when there are no equal signs present. So in this top one you can't do that. So what do? What we do is we try to find common denominators so that we can at least simplify it. So this is where I look at this here and say, is there anything here, over here, that I'm missing here? Well, this x plus y here is 1 unit, so I'm missing an x all by itself. So what I do is I bring the x over here and I put 1 up there. Then I look over here. What do I have here that I'm missing here? Well, I have an x plus y. And again, because it's got the plus sign between it, it joins those together and they can't be split up. So we don't have an x over here. We have an x plus y. So I put an x plus y here and 1 up here. Now I can put them all, this whole top over this bottom, and the bottom is a common denominator, so I can just leave it as x times x plus y written one time, and I've got 4x plus py times x plus y. And that's it for that. And so that's kind of a review over what we've done in the past. But there will be times where we have what are called complex fractions, and complex fractions are fractions that have fraction in the numerator and a fraction in the denominator. So for example, if we have x over y plus 4 over yx, and that's all over a over y. Alright, now here's the key thing about solving something like this. That key thing about solving something like this is that we do all the work above the division sign first, and we do all the work below the division sign. Okay, there's nothing we can do here because there's no plus or minus here, so that's just a fraction, because what we're trying to do is get this to be one fraction over one fraction. Okay, so that's our first step. Since this is only one fraction here, we're done. But this is two fractions, so we have to add those. And from what I just did earlier, I look at my denominators, and I've got a y here. What am I missing that I have over here? And I have an x. And then I look here. It's like, okay, what am I missing here that I have over here? Y? Nope, I've got a y. An x, well, I'm not missing an x, I have one, so I don't have anything that I need to do. So now I have common denominators, and that equals x squared plus 4, and I can put the whole thing over yx. I can bring those two together. And then that is over a over y. And if you remember from the olden days, when you want to divide fractions, you turn the bottom fraction upside down, and you multiply. So I'm going to rewrite this, x squared plus 4 over yx times y over a. Now the nice thing about that multiplication sign is I can cancel across it. If that were a plus or a minus I couldn't. But since a multiplication I can cancel those x's there. And I'm left with x squared plus 4 all over ax. And again, I cannot cancel this x, any of these two x's with this x because of this plus sign. That plus sign makes this not an x squared into 4, it makes it an x squared plus 4. So unless I have an x squared plus 4 down here, I can't cancel. So I am done with that one. So this is example 2, and again what we're going to do is we're going to get my bottom to be one fraction, which it already is, so that's good, I don't have to do anything there, and my top to be one fraction. So again, I'm going to look at this top and see what I am missing. So I've got an x plus y here, I'm missing a y, so I'm going to multiply top and bottom by y. And then I look over here, and what am I missing? I'm missing an x plus y here, so I'll do an x plus y and an x plus y. And I'm not doing anything to there. So let's look at this first term. I'm going to move it so it's alphabetical. That over y times x plus y, that's my common denominator now, so I don't have to write it twice, plus m times x plus y, and then that's all over x over a plus m. So all I'm going to do now is take this and flip it upside down and multiply it times that there. Okay? Alright, so I just moved everything up. So this is my problem where I'm at right now. So I've got to multiply a plus m times each one of these terms. I have to distribute that, and I end up with a bunch of yuck. So what I'm going to do here is I'm going to write a plus m over x, and I'm going to multiply that by a y plus m times x plus y over y times x plus y. Okay, so see what I did? I just took this problem right here and put it here, and this part here I put over here. Okay, I just flipped them around. Alright, so now let's distribute this m to the x and the y. So I've still got, I didn't do anything with the a plus m over x. Didn't do anything to that, but I'm going to distribute this. And I'm going to put that over, or I'm sorry, just a y. It's late. Like that. So that's all I did was distributed this m here and here. Okay, now let's see if I can move some of this up and out of the way. Alright, so this is what I have left here in white there at the bottom. Alright, so now what I have to do is multiply this a plus m times this, and times that. But in this particular problem, it's not going to make any change. So let's just put the a plus m, and we won't actually multiply it because it's not going to help us at all. Okay, and then we've got these two, so I can put those at x and y together, and we'll call that done. Doesn't really look very simplified, does it? But we're down to one fraction instead of 3 fractions, and that can be kind of a pain. So it is better, although it doesn't necessarily look a whole lot prettier. So that's it for lesson number 33 in Algebra 2.